In this lesson, we're going to cover Unit 7, Acquisition 2, percent by volume or percent by mass. The nice thing about these two calculations is the equation is the same. The only thing that's going to be different would be the units. So let's start with percent by mass or mass percent. This is just the number of grams of solute in each 100 grams of solution. So that's all that mass percent tells us. If I had 100 grams of solution, how much solute would I have? The way that we are going to calculate mass percent is we are going to take the mass of the solute. We are going to divide by the mass of solution, and then since it's a percent, we would multiply by 100. First example, a solution is made by dissolving 13.5 grams of glucose in 100.0 grams of water. What is the mass percent of glucose? The only thing that is tricky about these types of problems is you need to be careful about what you are given. I have 13.5 grams of glucose dissolved in 100 grams of water. The solute is what is being dissolved. The solvent is what it's being dissolved in. But notice my equation. I don't need the mass of the solvent. I need the mass of the solution. An abbreviation for solution is SOL''N, solution. Mass of the solution is going to be equal to the mass of the solute plus the mass of the solvent. So be very careful of the problem. If it said a 100 gram solution is made by dissolving 13.5 grams, that would be the mass of your solution. If it gives you the mass of the solvent, we need to do solvent plus solute. So the mass of my solute is 13.5 grams plus the mass of my solvent, which is 100.0 grams. Remember, when adding or subtracting, the least number of decimal places determines how many decimal places go in your answer. So I would have 1 decimal place. The mass of my solution is actually 113.5 grams. Once we get here, it's just plug and chug. Mass percent is equal to the mass of the solute, which is my 13.5 grams of glucose, all over the mass of the solution, Grams divided by grams are going to cancel. And then multiply by 100. Rounding to 3 significant figures, 11.9%. So again, all that mass percent is it tells us how many grams of solute I would have in 100 grams of solution. If I had 100 grams of solution, I would have 11.9 grams of glucose. Let's try another one. The percent by mass of isopropyl alcohol is 70.0%. How many grams of isopropyl alcohol are in 250 grams of solution? So in this case, we are not given the mass of the solvent. In this case, we're given mass of solution, so that's going to be my denominator. Percent by mass, 70%. I'm solving for grams of solute all over mass of solution. So first thing we would want to do is divide both sides by 100. And then I could multiply 250 times 0.7, and I would get 175 grams as the mass of my solute. Again, we always want to look at significant figures. 70.0 has 3 significant figures. 250.0 has 4 significant figures. We're always going to use the smaller number. Okay, we're going to do one more type of mass calculation. And we're going to do something slightly different if we have a solution that is very dilute. So it's not very concentrated. Very dilute solutions are expressed in parts per million. So if you had something that's very, very dilute, it's going to have a very, very small percent. So rather than representing it in mass percent, we're going to represent it in what's called parts per million, or ppm. It is essentially the same equation. We're still going to take the mass of the solute. We are still going to divide by the mass of the solution, but instead of multiplying it by 100, we're going to multiply by 1 million. So let's say you were asked, what is the concentration in parts per million if 0.0032 grams of sodium hydroxide is dissolved in 100 grams of solution. So we're going to take the mass of the solute. The solute is whatever is being dissolved. 0.0032 grams of sodium hydroxide is being dissolved all over the mass of solution. I have 100 grams of solution. And then let's multiply by 1 million. (32 parts per million). We always want to check significant figures. Leading zeros are not significant, so 2 significant figures, so my answer has 2 significant figures. Lastly, we have to do volume percent. Which is essentially the same thing as mass percent. Instead of taking the mass of the solute, we're going to take the volume of the solute. Instead of dividing it by the mass of the solution, we're going to divide it by the volume of solution. And since it's a percent, we want to multiply by 100. Let's say you were told a solution is prepared by dissolving 90.0 milliliters of hydrogen peroxide in enough water to make 3,000 milliliters of solution. So again, this is just plug and chug. These should be pretty easy calculations. We are dissolving 90 milliliters of hydrogen peroxide. Whatever is being dissolved is the solute. So my volume of solute is 90.0 milliliters. In this case, we are dissolving it in 3,000 milliliters of solution. So my volume of the solution is 3,000 milliliters. And then we want to multiply by 100 to get it to percent form. So when we do this, when we plug it in our calculator, we get 3. Let's look at significant figures. 90.0 has 3 sig figs. 3,000.0 has 1, 2, 3, 4, 5 significant figures. When multiplying or dividing, we round to the least number of significant figures, which is 3. So in order for our answer
to have 3 significant figures, I'm going to add a decimal place and 2 zeros.
3.00%.
You do need to be careful for volume. Just like
with our mass, be mindful of what they give you. The volume of the solution would be the volume of the solute plus the solvent.
So instead of giving you milliliters of solution, if they gave you milliliters of solvent, you would have to add those two quantities together. So be mindful of what you're given when you're doing these calculations.